Related topic with rational exponents is rationalizing a denominator using a conjugate pair. So this will be the last example of the lesson. In the numerator we have y to the 1/2 plus 4 all over y to the 1/2 minus 1. What I recommend is to convert the y to the 1/2 to the square root of y. And then we'll be able to treat this problem similar to how we've done in earlier lessons. We now see that we have the need for a conjugate pair. So we now copy and paste the denominator. But in doing so, we change the sign. That's how we'll get the inner and outer products to subtract out to 0 and remove the radicals from the problem. So I'll rewrite using parentheses to indicate the distribution very clearly. So we go ahead and distribute. Square root of y times square root of y is square root of y squared. Square root of something squared is just that something y. And then plus 1 y squared. Plus 1 square root of y. And then we'll distribute the 4. The denominator now. The inner and outer products. So that'll be this and this will simply be square root of y minus square root of y, which sum to 0. So I won't write it. I won't write those two products. That's by design using conjugate pairs. So instead I'll just do the first and last products. Those won't subtract out to 0. So square root of y times square root of y is just y. And negative 1 times positive 1 is negative 1. When working with real numbers, this will always be a negative because you have a positive times a negative. So what we do next is simplify the numerator. So we got y plus 4. Right there in the middle we have some like terms for a total of 5 square root of y. And nothing simplifies further than that, but before I box, because I started with a fractional exponent, I have to end with a fractional exponent for the final answer.